Have you ever wondered if our reality is truly real? Today, we're diving into the fascinating world of simulation theory, a concept that suggests our universe might actually be an artificial simulation, much like a highly advanced computer program. This idea has captured the imagination of scientists, philosophers, and even filmmakers. But what exactly does simulation theory propose, and why has it become such a hot topic in recent years? Let's start by exploring the basics and setting the stage for a journey that questions the very nature of existence. Simulation theory isn't just a modern sci-fi fantasy. Its roots can be traced back to philosophical discussions about reality and perception. Thinkers like René Descartes questioned whether our senses could be trusted, and more recently, philosopher Nick Bostrom formalized the idea in the early 2000s. Bostrom's argument suggests that if it's possible to simulate consciousness, then it's likely we're living in a simulation. This blend of philosophy and technology has sparked debates and inspired countless discussions about what it means to be real. At the heart of simulation theory is a compelling argument. If advanced civilizations can create highly realistic simulations, and if they have the motivation to do so, then simulated realities could vastly outnumber real ones. This means the odds of us living in the original, base reality might be incredibly slim. The theory hinges on three main possibilities. Either civilizations never reach the technological level to create simulations, they choose not to, or we are almost certainly living in a simulation. It's a mind-bending proposition that challenges our assumptions. Let's consider how far technology has come. From the first computers to today's hyper-realistic video games and virtual reality, our ability to create immersive digital worlds has grown exponentially. Imagine what might be possible in 1,000 or even 1,000,000 years. If future civilizations possess computing power far beyond ours, creating entire simulated universes could be within reach. This rapid technological progress forms a key pillar of simulation theory, making the idea seem less far-fetched than it once did. Simulation theory draws heavily from age-old philosophical questions. Descartes famously asked, "How do we know anything is real?" This skepticism about reality underpins much of the theory. If our senses can be deceived, and if it's possible to create convincing illusions, then how can we ever be sure of what's genuine? These questions have been debated for centuries, but simulation theory gives them a new technological twist, blending ancient philosophy with modern science. Nick Bostrom, a Swedish philosopher, brought simulation theory into the mainstream with his 2003 paper. He argued that at least one of three statements must be true. Civilizations go extinct before reaching simulation capability, they lose interest in running simulations, or we are almost certainly living in a simulation. Bostrom's logic is both simple and profound, forcing us to confront the possibility that our reality might not be the original one. Simulation hypothesis suggests that our entire universe, including ourselves, could be part of a sophisticated computer program. This isn't just about virtual reality goggles or video games. It's the idea that everything we experience, from the laws of physics to our own thoughts, might be coded into existence. If true, it would mean that our reality is fundamentally artificial, and that there could be countless other simulated worlds out there. Simulation theory has made its way into popular culture, inspiring movies, books, and TV shows. The Matrix is perhaps the most famous example, depicting a world where humans unknowingly live inside a simulated reality. These stories captivate audiences because they tap into our deepest questions about existence and reality. They also make the abstract ideas of simulation theory more accessible and relatable to the general public. One of the most compelling arguments for simulation theory comes from the world of video games. As our games become more realistic, with detailed graphics and complex artificial intelligence, it's easy to imagine a future where simulations are indistinguishable from reality. If we can create such worlds on our computers, who's to say a more advanced civilization couldn't do the same on a much larger scale? Artificial intelligence is another key factor in simulation theory. As AI becomes more sophisticated, it's not hard to imagine digital beings with consciousness, emotions, and self-awareness. If we can create intelligent agents in our own simulations, it raises the question, could we ourselves be such agents, created by a higher intelligence? The rapid progress in AI research makes this possibility increasingly plausible. Some scientists point to the strange behavior of particles at the quantum level as possible evidence for simulation theory. Quantum mechanics reveals a world that's unpredictable and sometimes seems to behave as if it's being observed, almost like a computer rendering graphics only when needed. While this is far from proof, it's an intriguing parallel that keeps the debate alive among physicists and philosophers alike. Have you ever experienced déjà vu or noticed strange coincidences that seem too perfect to be random? Some proponents of simulation theory suggest that these could be glitches in the simulation, small errors or inconsistencies that hint at an underlying artificial structure. While these experiences are usually explained by psychology, they add a layer of mystery to the theory and fuel speculation about the true nature of our world. Our senses are limited, and we only perceive a small fraction of reality. Simulation theory asks us to consider whether our perceptions are intentionally restricted, much like a video game only renders what the player can see. This analogy helps explain why we might not notice the artificial nature of our universe, even if it is simulated. It's a humbling reminder of how little we truly know about the world around us. Of course, not everyone is convinced by simulation theory. Critics argue that there's no direct evidence for it, and that it raises more questions than it answers. Some scientists believe that the complexity of consciousness and the universe itself makes simulation unlikely. Others point out that even if simulations are possible, it doesn't mean we're actually in one. These counterarguments are important to consider as we weigh the theory's merits. Major point of contention is the probability of living in a simulation. Some argue that if simulations are easy to create, there could be billions of simulated realities for every real one. Others counter that this is pure speculation, and that we have no way to calculate the actual odds. The debate over probability keeps the discussion lively and ensures that simulation theory remains a topic of interest. Some researchers have proposed experiments to test simulation theory. For example, they look for signs of pixelation in the fabric of space, or search for anomalies in physical laws that might indicate artificial constraints. While no definitive evidence has been found, these experiments push the boundaries of science and encourage us to think creatively about the nature of reality. Consciousness remains one of the greatest mysteries in science. Simulation theory raises the question, can consciousness be simulated, or is it something unique to biological beings? If we can create conscious digital entities, it would lend support to the idea that we ourselves could be simulated. This intersection of neuroscience, philosophy, and technology is at the cutting edge of modern thought. Fermi paradox asks why, given the vastness of the universe, we haven't encountered other intelligent life. Some suggest that if we're in a simulation, the absence of aliens could be intentional. Perhaps the simulation is designed to focus only on humanity. This idea adds another layer to the mystery and connects simulation theory to broader questions about our place in the cosmos. The anthropic principle states that the universe appears fine-tuned for life because we are here to observe it. Simulation theory offers a possible explanation. Perhaps the simulation is designed to support conscious observers like us. This perspective reframes the question of why the universe seems so perfectly suited for life, suggesting it might be intentional rather than coincidental. Physicists propose that the universe operates like a giant computer, processing information at the most fundamental level. This idea, known as digital physics, aligns closely with simulation theory. If reality is ultimately made of bits and information, it becomes easier to imagine that our universe could be a sophisticated simulation running on some cosmic supercomputer. Mathematics is often described as the language of the universe. Simulation theory suggests that the mathematical order we observe might be evidence of underlying code or programming. If everything in the universe can be described by equations, perhaps those equations are the rules of a simulation, carefully crafted by its creators. In quantum physics, the observer effect describes how the act of observation can change the outcome of an experiment. Some interpret this as a hint that reality only renders when observed, similar to how a video game only displays what the player sees. This analogy supports the idea that our universe could be a simulation, with resources allocated only when needed. One of the biggest challenges for simulation theory is the lack of direct evidence. While there are intriguing parallels and thought experiments, there's no definitive proof that we're living in a simulation. This doesn't mean the theory is false, but it does highlight the difficulty of testing such a profound idea. For now, simulation theory remains a fascinating hypothesis rather than a proven fact. If we are living in a simulation, what does that mean for our actions and choices? Some argue that it could change our sense of responsibility or the meaning we assign to life. Others believe that, simulated or not, our experiences and relationships are still real to us. The ethical questions raised by simulation theory are complex and invite us to reflect on what truly matters. People see parallels between simulation theory and religious ideas about creation and a higher power. The notion of a creator designing our reality echoes themes found in many spiritual traditions. While simulation theory is rooted in science and technology, it raises questions that have long been explored by religion and philosophy, bridging the gap between ancient beliefs and modern science. Whether or not we live in a simulation, the search for meaning remains a central part of the human experience. Simulation theory challenges us to think deeply about our purpose and the nature of reality. It encourages us to ask big questions and to seek understanding, even when the answers are elusive. Ultimately, the journey of exploration is as important as the destination. Many scientists remain skeptical of simulation theory, viewing it as an interesting thought experiment rather than a testable hypothesis. They emphasize the importance of evidence and caution against drawing conclusions based on speculation. This skepticism is healthy. ensuring that scientific inquiry remains grounded in observation and experimentation. Simulation theory demonstrates the power of human imagination. By envisioning realities beyond our own, we expand the boundaries of what's possible. Whether or not the theory is true, it inspires creativity and pushes us to explore new frontiers in science, philosophy, and technology. Imagination is the engine that drives progress and discovery. Simulation theory has had a profound impact on science fiction, inspiring countless stories about virtual worlds, artificial intelligence, and alternate realities. These narratives allow us to explore the implications of the theory in creative and entertaining ways, making complex ideas more accessible to a wider audience. As technology continues to advance, simulation theory is likely to remain a topic of interest. New discoveries in physics, computing, and artificial intelligence could provide fresh insights or even evidence for or against the theory. The future holds many possibilities, and the debate over the nature of reality is far from over. For many people, simulation theory is more than just an abstract idea. It's a lens through which to view the world. It invites us to reflect on our experiences, relationships, and the meaning we find in life. Whether or not we live in a simulation, the questions raised by the theory can lead to greater self-awareness and a deeper appreciation for the mysteries of existence. Technology is at the heart of simulation theory. Our ability to create digital worlds, simulate complex systems, and develop artificial intelligence all contribute to the plausibility of the theory. As we continue to push the boundaries of what's possible, we may one day create simulations as rich and detailed as our own reality. Simulation theory forces us to confront fundamental questions about the nature of reality. What does it mean for something to be real? How do we distinguish between illusion and truth? These questions have no easy answers, but they encourage us to think deeply and critically about our place in the universe. The simulation argument has influenced not only scientists and philosophers, but also artists, writers, and technologists. Its impact can be seen in everything from academic papers to blockbuster movies. By challenging our assumptions and sparking debate, the argument continues to shape the way we think about existence. If we are living in a simulation, what does that mean for free will? Are our choices truly our own, or are they determined by the rules of the simulation? This question has deep philosophical implications and adds another layer of complexity to the debate. It's a reminder that simulation theory touches on some of the oldest and most profound questions in human history. While simulation theory is intriguing, it's important to approach it with a healthy dose of skepticism. Critical thinking and scientific inquiry are essential for separating fact from fiction. By questioning assumptions and demanding evidence, we ensure that our understanding of reality is as accurate as possible. Simulation theory reminds us of the power of asking questions. By challenging what we think we know, we open ourselves up to new possibilities and discoveries. Whether or not we ever find definitive answers, the act of questioning is itself a valuable pursuit. Evidence is the cornerstone of scientific inquiry. While simulation theory offers many intriguing ideas, it's important to remember that extraordinary claims require extraordinary evidence. Until such evidence is found, the theory remains a fascinating possibility rather than a proven fact. At its core, simulation theory is a testament to the human drive to understand our world. We are constantly seeking answers, pushing boundaries, and exploring new ideas. This curiosity is what makes us unique and propels us forward, no matter how strange or challenging the questions may be. Simulation theory highlights the limits of human knowledge. There may be aspects of reality that are forever beyond our understanding, no matter how advanced our science becomes. This humbling realization encourages us to remain open-minded and to continue exploring, even when the answers seem out of reach. Exploring ideas like simulation theory is valuable, even if we never find definitive answers. The process of questioning, debating, and imagining helps us grow as individuals and as a society. It fosters creativity, critical thinking, and a deeper appreciation for the mysteries of existence. Simulation theory sits at the intersection of science and philosophy, blending empirical inquiry with deep existential questions. This unique position allows it to draw from both disciplines, offering a rich and nuanced perspective on the nature of reality. It's a reminder that some of the most important questions can't be answered by science alone. The discussion around simulation theory is enriched by the contributions of a diverse community of thinkers, from scientists and philosophers to artists and technologists. By sharing ideas and engaging in dialogue, we collectively advance our understanding and inspire new ways of thinking about reality. Simulation theory opens the door to endless possibilities. If our universe is a simulation, what else might be possible? Could there be multiple simulations, or even simulations within simulations? These questions stretch the imagination and invite us to consider realities far beyond our current understanding. In the end, simulation theory is as much about embracing mystery as it is about seeking answers. Whether or not we live in a simulation, the questions it raises encourage us to think deeply, remain curious, and appreciate the wonder of existence. The journey of exploration continues, and the mysteries of reality remain as captivating as ever.